Well, hi there. In our last video, we were talking a little bit about some vocabulary to this field of trigonometry. Today we're going to use some of those ratios that we talked about, being sine, cosine, and tangent, to actually be able to solve missing parts on right triangles. So maybe they'll give us a side and an angle and ask us to find the length of another side using trig. So we're going to look at a couple examples today doing that. You're going to want to have a graphing or a calculator with you that's capable of making these trig calculations for you. Whatever you're watching this on probably has that capacity. You just got to find it. It might be easier though if it's like a standalone item, so you don't have to keep going back and forth to the calculator and stopping the video. But whatever. If you ever have to write an equation to find a missing side length on a right triangle, first thing you're going to want to do is pick one of the two acute angles to work off. A lot of the times it won't matter which one, just kind of pick one and get rolling. Then determine the relationship between that angle and a side length that you know. So is that side length that you know, is it the opposite of the angle you picked? Is it the adjacent of the angle you picked? Or is it the hypotenuse? Also, you need to figure out what's the relationship between the acute angle that you picked to work off of and the side that you're looking for. Again, is it the opposite? Is it the adjacent? Is it the hypotenuse? Then take the information that you came up with in steps 1 through 3 and write a trig equation. If you're using opposite and hypotenuse, you'd want to use a trig equation that involves sine, for example. Then solve that equation, round off your answer. As a rule of thumb, we'll go to the nearest tenth, so like 1 decimal place for all these answers. Let's see these steps in action via an example. We've got a triangle where we're given one measure, angle B, I'm going to label as 25 degrees. And side A, that would be this side, which is opposite angle A, is 14.2 feet long. We need to figure out the length of side B, which would be this vertical side across from angle B. So the first thing I'm going to do is pick an angle to work with here. Since they gave me angle B is 25 degrees, I think I'll just go ahead and pick that as the angle I choose to work with. Next, we need to determine the relationship between that angle and a side that we know. Well, if the angle I'm working off is B, and I know this side is 14.2, that side is actually adjacent to the angle I'm using as my reference. Determine the relationship of the side that you need. Well, the side that I need is this vertical side, which is opposite the angle that I'm working off. Next, write an equation using this information. So I need to write a trig equation using adjacent and opposite. And the trig ratio that uses adjacent and opposite is tangent, TOA. Tangent is opposite over adjacent. So what I can say is the tangent, and I don't just want to say tan, I want to say tangent of something. In this case, the tangent of this 25 degree angle is, and I want to go opposite over adjacent. Opposite is I don't know. I'll call that little b, because that's the side B, over adjacent, which is 14.2. If you take a calculator, it has stored in its memory what the tangent of 25 degrees is. It has that. It doesn't write it as a ratio like we were doing yesterday, like 3 over 5 or 10 over 6. What it does is it stores it as a decimal. So we've got tangent of 25 degrees. You want to make sure your calculator is in degree mode. If there's a DRG button, make sure the D is lit up on the screen. In this equation, to isolate the B, I would multiply both sides by that 14.2, because to get rid of a denominator, you multiply both sides by that number. So I would end up with 14.2 times tangent of 25 degrees equals B. If you type in 14.2 times tangent 25, and on some of your calculators you might have to do 25 first and then hit the tangent button. We can talk about that in class if you can't figure out how to get your calculator to work. But when you multiply the 14.2 by this tangent, you should get about, let's round it off, to about 6.6. That's the nearest tenth. That's why I'm using the approximately equal to sign to indicate that I did round that answer off. Another example. Here we've got a 22-degree angle for B, and now we know that side A is 8.1. And they're saying find the length of side C. Well, that's the hypotenuse this time. In this case, I'm going to use angle B to work off of. I know the adjacent side, and I need the hypotenuse. I know this 8.1 is the adjacent. I need this side C, which is the hypotenuse. So if I'm going to write a trig ratio, I'm going to use the one that has adjacent and hypotenuse in it. Well, that's cosine. So I'm going to say cosine of my angle, which is in this case 22 degrees, equals adjacent over hypotenuse is 8.1 over C. Now this is tricky because the thing that I'm trying to isolate is in the bottom of a fraction. So I can multiply both sides by C, even though that won't isolate the C. That's all right. That's a good first step. So I'm going to say C times cosine of 22, because I got to multiply the left side by C, and I'm going to multiply the right side by C, which will simply get rid of the denominator for me. And just leave me with 8.1. Then to isolate the C, I need to divide both sides by cosine of 22. So C by itself is going to be 8.1 over the cosine of 22 degrees. This is a great calculator problem. If you type in 8.1 divided by cosine of 22 on your calculator, it should round off to about 8.7. Again, 8.7 is longer than 8.1. That's good because the hypotenuse is the longest side on the triangle. It doesn't guarantee you're right, but it's pretty darn reassuring in my book. What we've been doing now so far is finding side lengths. The sine and cosine and tangent ratios are used to do that. They're used to find side lengths. When you already know an angle measure. Sometimes the situation will be reversed. You may need to find an angle measure when you already know two side lengths. Well, if they are reversing the question, then you will need to invert the function. You will need to use what is known as an inverse sine, or an inverse cosine, or an inverse tangent. If you're old school, they might call this arc sine, arc cosine, or arc tangent. Sometimes I'll slip up and say that because I was educated in 1862, and that's just how we talked back then. But generally, we'll call it an inverse trig function. So here's an example of that. The sine of an angle is 4/5. I'm going to literally write that down. Sine of x. X is my angle. I don't know how many degrees it is. I'm just going to call it x. Because you always got to have sine of something or cosine of something. You can't just say sine equals. That doesn't make any sense. But you can say sine of some unknown angle is 4/5. What is the measure of that angle? Well, x is my angle. X is what I want to isolate. In order to isolate it, I've got to get rid of the sine function in front of it. To get rid of the sine function in front of it, I need to invert it. I'm going to apply inverse sine to both sides. That's how it appears on your calculator. It appears to be a -1 exponent. I assure you a bazillion times over, it is not, in fact, a -1 exponent. It is a symbol in math that means inverse. Why in the world they chose two different functions to be represented by the same symbol and confused generations of math scholars, I have no idea. I was probably not invited to that meeting. We're going to apply inverse sine to both sides of this equation. When I apply inverse sine to the left side, I quote-unquote cancel out the sine function. That just isolates the x for me. When I apply sine inverse to the right side, I literally have sine inverse of 4/5. This is a great calculator problem. The way that you access inverse sine is usually to use the shift or the second button if you're using a standalone calculator. So I am going to keystroke second sine, and then in parentheses 4 divided by 5, because 4/5 is simply 4 divided by 5. That gives me a result of about 53.1. The result that I'm getting, 53.1, is an angle measure, because by using inverse sine, I am getting an angle measure. Therefore, my label should be degrees, because that is what I am asking my calculator to give me, degrees. The sine inverse button means exactly that. It means sine inverse. It does, or inverse sine. It does not mean a negative first power. It can also be called, inverse sine can be called arc sine. It means the same thing. It's tempting to start saying second sine, because that's what we keystroke on our calculators a lot of the time to make the calculators perform that operation. We'll hit the second button in the sine. Please don't be in the habit of calling it second sine. It's called inverse sine. So we want to speak English, not calculatorese. Another example using some inverse trig operations. It says side A is 22.2, side A is down here, centimeters, and side B is 13.5. Side B is over here. What's the measure of angle A? So again, when you're looking for an angle measure, you need to invert your trig equation. We're still going to set it up the same way. I'm still going to say, well, obviously A is the angle I want to work with. And I know two things here. I know two sides, because there's always three things. There's an angle and two sides. You got to know two of the three things. The first couple examples we looked at, we knew the angle and we knew one of the sides. That was good enough. We had one unknown side. Here, we don't know the angle, which means, the sides better, pick up the slack. We better know both of them. And we do. We know the opposite, we know the adjacent. If we know the opposite and we know the adjacent, we can write an equation involving tangent of angle A, because we know A is opposite and adjacent. All right. Specifically, we can say the tangent of A, I'm going to have to call it A because I don't know the measure, is 22.2, that's the opposite, over 13.5, that's the adjacent. If I want to get rid of this tangent function, I need to apply inverse tangent to both sides. If I apply inverse tangent to the left side, I successfully get rid of the tangent function and just isolate the variable. That's perfect. On the right side, if I then apply inverse tangent, I get inverse tangent of 22.2 over 13.5, which is, again, a good calculator problem. I'm going to hit the second button, I'm going to hit tangent, and then in parentheses, I'm going to do 22.2 divided by 13.5. And I'm going to get about 58.7 degrees. So a quick quiz to wrap up here. This is me really fixating on vocabulary and saying the right thing. How would you go about solving the following equation, cosine of x equals a half? Pause this if you would. Alright, I guess if I'm tackling this, I look at A and I say, I'm not applying the cosine function. The cosine function's already being applied. I look at B, I say, there is no such thing as cosine to the negative first power, so that gets eliminated. I look at C, I say second cosine, that's calculator talk. Real math students don't say second cosine, they say inverse cosine. Oh wait, that reminds me, that's the answer in D. And just to make sure, E is apply the sine operation. Sine has nothing to do with this problem, so your answer is D. Hope you enjoyed your harmless little quiz, and hope you get some good practice on some of these trig problems.